Dear students, welcome to the part B discussion of the physical database design and tuning. In this discussion, we are going to understand the importance of database tuning. In the part A, we have discussed about the database design and the database design decisions that we make in order to make the database perform faster. In tuning, we are going to discuss certain techniques that will help the DBMS tune the database for a better performance. Now, let us understand what is tuning all about. Database tuning actually helps the DBA manager to take care about the database management efficiently, as much as efficient as possible. What is the process of database tuning? Let us understand it. Database tuning is a process of optimizing. It is a process of optimizing. When we talk about optimizing, it means increasing the efficiency and reducing the resource consumption. So, database tuning is defined as the process of optimizing a database management system and the underlying database in order to improve the performance and efficiency. Sorry, the database the DBA is to ensure that the queries and the operations are executed as quickly as possible and as efficiently as possible while minimizing the resource consumption. So this is the aim of database tuning. Fine tuning the database so that it yields you the query results as efficient as possible. In this discussion, we are going to see how this optimization while reducing the resources can be performed. Let me check if the video recording is going proper. Okay, good. Alhamdulillah. Now, tuning. We talk about tuning. And now let us see the formal definition of tuning. The tuning is a process of continuing. Okay, it is a process, it's an ongoing process. So the process of continuing to revise or adjust the physical database design by monitoring the resource utilization as well as an internal DBMS processing to free up the bottlenecks or to reveal the bottlenecks, such as keeping the same data for a longer time, like such as contention for the same data or devices. So we understand that tuning is an ongoing process, okay, and it is helping us to adjust the physical database designing. For example, you have designed the database, but after a month, of work on the database, you feel that it is not efficiently efficiently designed. After monitoring it for 1 month, you think that the DBMS is not designed properly. So in tuning, you're going to take care about updating it. Okay, and the other thing is that you will keep on monitoring the internal DBMS processes to reveal the bottlenecks, to reveal the limitations or reveal the limitations or the bottlenecks, that such as keeping the same contention is like holding the same data for a longer time, so that other queries or the transactions feel difficulty while accessing the data which is which is held by the DBMS for a longer time. What is the goal? Why do we do that? Why do we monitor? Why is that we need to monitor or keep an eye on the processing to free up the bottlenecks? What is the need of doing it? The goal is to make the application run faster. This is the first goal. And the second one is to lower the response time of the queries and the transaction, okay, and to improve the overall throughput of the transaction. So in order to do these three things, the DBA has to monitor the resource utilization and the internal bottlenecks, ongoing bottlenecks or related to a DBMS. Okay, so this is the goal, and this is the action in order to make this goal possible. Let us see what are the other ways. Understanding the internal statistics collected by the DBMS for understanding the size of memory each individual table is occupying, understanding the number of distinct values in a column, the third one, the number of times a particular query or a transaction is executed in an interval of time, how often it is executed, as we have seen in the part one also, where we see that how frequently a query is invoked over a period of time. Okay, so we do this here. The result of that one, we look it into the statistics. So this is all related to the monitoring. What do you monitor? We said, the first one in the tuning definition, we said that the DBA is going to monitor the resource utilization. Okay, so what is he monitoring on? He's monitoring on the size of the table, number of distinct values in a column, a number of times a particular query or a transaction is executed over a period of time, on a period of time. And the fourth one is the time which is required for different phases of a query and the transaction processes. So a query have different phases, like a query is first converted into a relational database, relational algebra, and then a relational algebra tree is constructed, and then first optimized way of executing the query is identified, and then the query is executed. And also the transaction also have different phases. You remember the transaction has an active phase, or it has a rollback phase, or it has a running phase, it has a safe a commit phase. So the time required for different phases of query and the transaction processing is also monitored, like how long a query or a transaction is taking to run to the completion successfully. Okay, the second thing is the statistics obtained from the monitoring include the storage statistics for the DBMS, and the things related to the DBMS. The IO and the device performance on the statistics is also obtained in monitoring. Query and transaction processing statistics, logging. Now we have talked, okay, so logging is a process. Logging is what we study in the concurrency control, wherein each transaction put a log on a database item so that other transactions cannot access it, and this ensures that we are controlling the concurrency. Okay, so logging and logging related statistics, maintaining a system log, okay, all those things are also monitored. And indexing the statistics related to the index. So we talk about the index, the way how we create the indexes and the statistics on the index. So these are the data or the information things that are obtained after monitoring the database: storage statistics, IO and device performance statistics, query transaction processing statistics, logging and logging related statistics, and index. So how many are there? There are 5. Okay, and related to what do you collect the internal statistics of DBMS? Related to the, again, there are 4. First one, size of the individual table. Second one, distinct values in the column. Third one, the number of times a query or a transaction is executed over a period of time. And the fourth one is the time required for different phases of the query and transaction processing. Okay, now what are the problems that you need to be aware when you are performing the tuning of the database? The problems that have to be considered in tuning includes how to avoid excessive log contention. Contention means holding a particular thing, for example, the results are, the contention of results. For example, if somebody do not, pay the fees, their results are not revealed. So a contention is something like that. So when a transaction wants to work on a data item, it will lock the data item. If it needs another data item, it will lock that one also, to make sure that these two data items are not disturbed by another transaction. Now, when a transaction keeps on locking the data item and it does not reveal it, what is the problem? What will be the problem? The problem will be the other transactions will not be able to use these data items, and they have to wait. For example, if I am reserving, room number 1011 at 7:30, and then I'm also reserving 1022 at 7:30 in the same day. It's like, other people cannot use this room because I have reserved it, and they are going to wait for me. So in order to avoid excessive log contention, it is very important for the DBMS to look at how to avoid the excessive log contention. contention. Otherwise, the other transactions have to wait. The second one says how to minimize the overhead of logging and unnecessary dumping of the data. In many cases, we try to store the data that is not used or that will not be useful for the database user, or we might not use it even for the DBMS purposes. So we can see the DBA has to see how those how those overheads can be minimized for the data that is not necessary. Third one, how to optimize the buffer size and scheduling of the process. We know that a buffer is always needed when we want to read a disk block and transfer it into the memory, or bringing the or reading a variable from the disk block and putting it inside the main memory. We need to have a buffer size. If the buffer size is optimized, not very big or not very small, if it is optimized, then the scheduling of processes becomes easier. And then the fourth concern that you have to take care about is the way how to allocate resources such as disk, random access memory, and the processes for most efficient utilization. How you allocate the resources for the data in that includes disk and RAM processing. So these are the four questions that you have to consider while tuning. These are the four problems actually that for which the tuning is required. The first one, how to avoid excessive log contention. The second one, how to minimize the overhead. The third one, how to optimize the buffer size. The fourth one, how to allocate the resources. Now let us see. Let us talk about tuning the indexes. What is the need to tune the indexes? We have so many reasons to tune the indexes, and there are different options to do that. The first reason to tune the index is that certain indexes may take too long to run. And then what happens, the index itself is taking long to run, and then if you have a search inside that index which is taking longer to run, of course the search will also take a longer time to run. So certain queries may take too long to run for lack of an index. Now if you might have some queries that are taking long time because we don't have an appropriate index created for it. So what is the solution? Build a new index for the queries which is taking too long to run. Okay, now the second one is that certain indexes may not get utilized at all. So what is the solution? Drop the index because it is not using at all. You created an index to to search or to insert, but for example, after the course registration, like after the midterm exam, there is no student allowed to register for the course, and there is no student to delete the course right after the midterm exam. So if we have queries or indexes that are helping us to insert or delete the courses, we might not need them after conducting the midterm exam. So certain indexes may not be used, but still they are using the resources related with the DBMS, right? So in that cases, we can drop the indexes. Now, the third one is certain indexes may be causing excessive overhead because the index is an attribute. Okay, certain indexes may be causing excessive overhead because they are kept on an attribute that are changed frequently. So the field on which we make an index is not supposed to change, because if the value inside the attribute on which field we have made the index changes, the it will disturb the index as well, right? So if we try to keep an index on a field value or on the field whose values are keeping on changing, then the disturbance will even be caused for the index performance. So in that case, rebuild the index on a new field, okay, which is not changing that often. Okay, now the other one is change a non-clustered index to a clustered index, or vice versa. In some cases, we have learned about different types of indexes: a clustered index, non-clustered index, a primary index, or a secondary index. Now, if you have the index which is non-clustered, like primary or a secondary index, you might consider changing it to the clustered, or change the vice versa, or make the vice versa change. It means if you feel the primary index is not useful, you might consider changing it into clustered. Okay, so these type of options are possible for tuning the indexes, and there are three reasons why we would need to tune the index that we have just discussed. Now, the database design can also be tuned. Now, what do we do while tuning the database index? The database design. Dynamically change processing requirements need to be addressed by making changes to the conceptual schema. Now, here we are talking about the changes that we are going to make in the conceptual schema and the physical design also, if necessary. And to reflect those changes into logical schema and the physical design, the tuning can be performed wherever you feel that the requirements are changing. So you need to make a change in the conceptual schema, and if required, you have to make these changes reflected in the logical and the physical design schema. So here, in tuning the database design, you are making changes into this conceptual schema, or the logical schema, or the physical design as required to make the performance better for the database. Okay, and now the third one is tuning. The other one is tuning the database design. Tuning the database design. Possible changes to the database design. What are the different changes? Now there are 1, 2, 3, 4, 5 places where tuning the database design is required. So the possible changes that can be performed by tuning the database, the database design includes the following thing. The first one, the denormalization can be done because the certain attribute from two or more tables are frequently needed. So then you remember, what do we do in the normalization? We make the logically related fields to form a table. For example, all the fields related to the students will go inside the student table. All the fields related to the courses will go in the courses table. All the fields related to the instructors will go in the instructor field. But during exam, we might use certain fields out of these three different tables very frequently. For example, assume that final exams are running. So in the final exams, we would need the instructor, the classroom number, the students inside the classroom, and the course exam. These fields will be access maybe 3 times a day for running 3 exams in a day for different levels of the college. So instead of getting these 4 pieces of information from 4 different tables, we can denormalize and make one table specifically, or a view specifically for the exam, so that we save our time for getting the data out of different tables. Okay, the second one, for a given set of table, there may be alternative design choices, all of which achieve 3NF or BCNF, or may be replaced by other. So what does this say? For a given set of tables, okay, there may be a different choices. For example, if the database is on a 3NF, okay, or BCNF, like a fourth normal form, one of may be replaced by the other. So you can decide to at least change the level of normalization your tables are following, because you want to increase the better the performance. Okay, so this is also possible. The third one is a relation that forms R with the fields K, A, B, C, D. Okay, that is in the fourth normal form. BCNF can be stored into multiple tables that are also in BCNF by replicating the key, the K in each table. So it says that if you have a table in the fourth normal form, then it can again be stored into multiple tables by using this key. For example, I can have one table created by using this K, A, B. This becomes my one table. Okay, I can make, the other table by saying K, C, D, because this primary key is going to connect me the two splitted tables to fetch a record. So in the second point, we are saying that all changing from third normal form to fourth normal form is also a solution. And here it is saying that if you are already in the fourth normal form, we can again divide the table. So one point is saying that uh, denormalizing is possible, and here it is saying that if required, normalization is also a possible solution. So if you think denormalizing is helping you tune the database, go for it. If you think changing the normal forms levels is going to help you tune the database, go for this. If you are again thinking that in the BCNF, if you are going to create multiple tables and then you in the performance can be tuned better, then go for this one. Okay, now the fourth point is attribute related to the attributes. The attribute from one table may be repeated in another, even though this creates redundancy and potential anomalies. So this is also possible. You remember when we were talking about the rules of normalization in database concept, we say we want to eliminate the redundancy. But if this redundancy is helping you tune your database, then it is possible to use one attribute getting repeated in different tables, even if it is causing potential anomalies. But if the tuning is our perspective or the priority, then we might afford this redundancy. Okay, the last one is to apply the horizontal partitioning or the vertical partitioning. Now, what is this partitioning talking about? When you have a database, okay, or when you have a table and you want to partition the table into two halves horizontally, then it is called as horizontal partitioning. Okay, for example, I can have the bank employees or the bank customers data table in a form of horizontal partitioning, wherein I will say that the customers inside Mubarras makes one horizontal partition, the customers inside Hufu will make another partition. Now, if I have to search for a customer who is in Mubarras, I will just go to that partition and then I will search within it. I will not come into the partition of the Hufu and waste my time. So horizontal partitioning and vertical partitioning can also be performed if you want to fine tune your database. Okay, now how do you tune the queries? Indication for tuning the queries: a query issues too many disk access. Okay, now what are the disk accesses? A query can have indication. Okay, so here how do you tune the queries and what is the need for tuning the queries? Here it says that there is a need for tuning a query if a query issues too many disk access. Yeah, if you have a query that is resulting in accessing, in making too many access to the disk, then you have to make sure to reduce it. Now, for example, we have talked about indexes that help us to reduce the query disk access, right? So perform some actions like that. Yeah, using a binary tree, using a B plus tree, using the multi-level indexes, we are actually reducing the number of disk accesses. So we have to see if the query is making too many disk access. So we can, use one of the techniques to reduce the access, this access numbers, right? The second one is the query plan shows that relevant indexes are not being used. Then there is a call for tuning the query. Now, what is a query plan? Now, whenever you write a query, what happens? The SQL query is translated into a relational query, and the relational query creates a query tree to find the optimized way of executing it. Now, when you are seeing the query plan, it is showing that the relevant indexes associated with the query are not being used. So there is a need to fine tune the queries. Now, there are other more situations which requires the tuning of queries. Typically, that includes instances for query tuning. The first one is in some situation involving using of correlated queries, comma, temporaries are useful. You remember we have the concept of correlated queries, right? A query inside a query. Okay, so correlated queries in some situations and temporary in some examples, they are useful, so we might use it. If multiple options for join conditions are possible, choose one that uses a cluster index and avoid those that use string combinations. So if you have different options for joining the tables, okay, then choose one that is connecting with the other table by using a cluster index and avoid the string comparisons as much as possible. The third one is the order of table in the in the from clause may also affect the join processing. You remember we have talked about the left join, right join, leftmost, upper join. There's so many join type of ways exist in which you combine two tables. So if you have if you are joining two tables, placing the tables in the left side and the right side is also going to matter a lot. So when you're saying select student number comma teacher name, student name comma teacher name from teachers comma students, okay, where the course is equal to DBMS. So what it will do, it will do the comparison between the student name and the teacher name from the student table and from the teacher table. So now, of course, we have so many, large number of students than the teacher. So if you place the student table first, it will go and search all this, get all the students and then the teacher. So it is like the searching is done from the student name, and the student names are maybe 10,000, so 10,000 scans are needed. Then if I have 100 teachers assigned to this, connected to this, then with this 1,000 multiplied by 100 will be the scan required. But if I put the teacher name first, okay, it will do the scanning less number of times. Okay, so if I have 100 teachers and 1,000 students, so it will check one student, one teacher, and then the 1,000 number of one teacher with 1,000 number of students comparison where the course name is equal to DBMS. So it says that when you are having when there is a need to bring the data out of two tables, placing the arranging the tables after the from clause is also very important. Some query optimizers perform worse on nested queries compared to the equal of unnested counterparts. So changing a nested query into an unnested query is an option here. Okay. You remember what is nested query? A query inside a query. So in such cases, we can convert the nested to unnested form. Okay, the last one. Many applications are based on views that define the data of interest to those applications. Sometimes these view becomes overkilling. So what does it mean? We have a view that define the data of interest. So, okay, what is a view? Many applications are based on the way how the user wants to view the data in the application, but sometime a bad design of this application view will make the performance very bad. So we have to have a better way of presenting the data on the application so that it is sync with the database in a better way. Okay. Now, what are the additional query tuning guidelines? Query tuning guidelines, there are three. A query with multiple selection conditions that are connected by using OR may not be prompting the query optimizer to use any index. Okay. So when you have multiple query conditions that are connected with OR, it might not be very prompting, very useful for the query optimizer to use any index. Such query may be split up and expressed as a union of queries, each with a condition on an attribute that cause an index to be used. So it is saying that if you have a big query with multiple conditions inside it and they are connected with OR, they might not be very prompting to use the index. In such cases, what can we do? We can split the query and express as executing the union of those queries with a condition or an attribute that causes an index to be used. Okay, the second one, apply the following transformation. Not condition may be transformed into a positive expression. Okay, now if we say yeah, we have an operator called as not. We can say select all the students GPA not 4. Okay, for example, it is going to return me the students with a GPA whose GPA is not equal to 4, maybe less than that, maybe more than that. Okay, so in that case, we can convert this not condition into a positive expression. Okay, by saying get me the students whose GPA is less than 4, for example. By saying not, we are just trying to change it into positive. Okay, for example, if I say we don't have exam on 5th, I could rather say we have exam on 4th. Okay, so instead of using a not condition, using a positive expression. The other one is embedded select blocks may be replaced by joins. Okay, so here we are saying, for example, if I have a query and a subquery inside it, for example, select star from employees where employee is greater than 4, then I will say select star. Inside it, I will say where I will say select department from department where employee is equal to a condition. So here we are having two select statements that can be easily converted into a join. So we don't want a select inside a select, rather we prefer to join the two queries. Okay, if an equality join is set up between two tables, the range of predicate on joining attribute setup in one table may be repeated for other table too. So if we have an equality join, okay, for connecting two tables, the predicate of the condition of joining attribute can help us set up in one table. What helps us in setting up one table may also be repeated for other table. Okay, now let us talk about how we can optimize the where condition. Where condition may be written to utilize the index on multiple columns. So we can utilize the where condition to be rewritten, okay, to utilize or use for the indexes on multiple columns. Okay, so that is it. In this discussion, we have talked about the tuning the database, tuning the using the statistical information, problems that are considered in tuning, and we also discuss about why and how to tune the indexes. We saw how to what is the need for tuning the database design and the need for tuning the queries. Okay, so with this we complete the second part of the physical database design. Okay, thank you so much.